Hello all. So we've been hearing about platforms quite a bit since morning. What is a platform? What comes to mind? So I thought I'll start there. Um, so if you look at, let's take the example of hotel chains of the world. Um, their way of creating value is adding more inventory. Making more rooms available, making more facilities available, and that's something that we can call the stuff approach. Um, and once you have a lot of stuff, you need to connect supply and demand, and you need to reduce wastage, and that's where the optimization approach comes in. So if you look at the optimization approach, these aggregators like Make My Trip or Kayak and the many players in that space, they try to connect the inventory with the users, right? And the platform approach is where you start on a journey, the start, you don't know how it's going to end, and you want to be able to pivot based on how the players in the ecosystem. So it's all about ecosystem play. You want to see how players in the ecosystem derive value. They put demands on the system, and so it is important for the tech powering a platform to be able to support the pivot needs of the platform. So moving on, when you think of building a diverse platform, you cannot have monolithic mindsets. You have to have polyglot thinking. You have to have a very modular, a data-driven, automation-focused, and an API-based and open to extension thinking. We'll look at what some of these means and how these are leveraged in Sunbird in the next set of slides. So when you say modular, what it means, I spoke about how when you start on a platform, you probably cannot envision how the end would be. I mean, and you can think of any of the platforms in digital India that we heard about, and it's quite clear that what was envisioned 10 years ago is not what it is right now. So it is important that the tech stacks that power some of these platforms, or the building blocks thinking is quite important, because those capabilities can be leveraged to pivot and move forward in the directions where the market sees value. So modularity, automation, and data focus, and API driven is key here. And we've taken a lot of these tenets of how to build a platform, and we've created these architecture principles, which is central to anything we have thought and done in Sunbird. Okay, I'm not going through the details, but I'll just call out some of the important ones. You will see some of the terms overlapping with what was there in the previous slides. There's a mention of observability. We'll look at how that works. There's mention about scale, resiliency, extreme automation, ensuring, the human being errors, all that is removed, by having automation. So all that is important. So these are the architecture base principles that we use in anything that we've done so far in Sunbird. Okay. Now, let's imagine if we want to build a platform, if we want to start building a platform right now, I want to focus on what is an application focus area, what is the DevOps thinking, what is the data thinking, and then we'll see how Sunbird has embodied some of those thoughts. So any modern platform that needs to be built, that this is what the application or the systems thinking needs to focus on. You want to have a non-blocking and resilient system. You want it to be non-blocking so that it can scale horizontally. You want it to be event-driven, and you want it to be cloud native yet cloud agnostic, because you don't want a tie-in to a platform is not worth it if it can only run on a predefined set of infrastructure. And security and traceability are crucial as well. Now, I want to take us a bit of deep dive into how some of these focus areas have been implemented in Sunbird. Now, if you look at non-blocking, one of the basic things when you build massive scale systems is you want to auto scale. And if you want to auto scale, you want your workloads, when I say workloads, APIs and things like that, to be able to scale out. You want them to be able to scale out when they start utilizing the available infrastructure, and then you can put automation rules in place. So it is important to have non-blocking code in anything that you do, so that non-blocking code allows you to maximize the utilization of CPU and the resources available on the system. And we use the actor model, which is one of the ways of implementing async non-blocking applications. So we use the actor model, and we don't use it directly. We use the play framework, which internally uses the actor model. And when you use play framework and actor models, you get a lot of resiliency capabilities tagged along with it, because it's resilient by design. And in the next set of sessions that we're going to go a bit into how the code is structured and how we are leveraging the actor model and things like that. Talking about horizontal scalability, when you build microservices, it's important that the services are stateless, and then all state is stored in the system of records. And you can't just scale the microservices, because those microservices instances are going to connect to your databases. So you also need databases which can scale out horizontally. So we've chosen Cassandra, while we are polyglot in terms of persistence, but a lot of the transactional data is actually stored in Cassandra, and Cassandra has near linear scalability. We've tested it, and you can literally add more and more VMs and it'll just scale out. And that's how we've been able to power some of the throughput that was mentioned in one of the earlier sessions, 25,000 transactions a second. That's possible because we have all layers which are horizontally scalable. You have the database, which is horizontally scalable. You have the application layer, which is scalable. And you have your edge systems also, which will play in tune. Event-driven design, the moment you think microservices and the moment when you've spoken about non-blocking and async, you want to be able to make systems respond to things happening in the infra. So you need a set of events, and you need the system or the microservices to be able to react or respond to those events. So that's a very key aspect of any scalable system, and any async strategy usually relies on an event-driven architecture. Cloud native and agnostic. So how do we be cloud agnostic? It's quite easy to tie yourself to a cloud, but then you will realize that there are when you look at adoption, there are policies where certain corporations would have affinity to certain clouds, and or maybe certain people have their own data centers. So it is important to be able to be deployable across wide infra use cases. So we have enabled by that, by making small design decisions. For example, cloud storage is one place where we see that there's a lot of cloud tie-in that happens. Usually, if you build applications on Amazon, you kind of tie yourself with an S3. If it's Azure, you tie yourself with a blob storage. Likewise for GCP and OCI. So what we've done is we have abstracted that layer out. We have a cloud storage SDK, which handles all these nuances. And the application relies on the cloud storage SDK. So we've solved it through design, right? So cloud agnostic thinking is very, very important in any platform's journey. When you start building a platform, you tend to focus on perimeter security. You start to think that you want to have control over who is getting in and accessing your platform. But over time, you want to kind of shift to a zero trust model, where you wouldn't want to trust the microservice which is running next to you, right? And that's what we have done in Sunbird. So we use API gateways, we use reverse proxies, and we use a lot of architecture infra best practices to ensure perimeter security. And for fine-grained security, we have actually implemented a stack called OPA. So OPA runs in Kubernetes along with your microservice, in front of your microservice, ensuring that you can fine-tune the rules based on which the calls can come into your service. And that is not done by the developer. That can be an overlay layer which can be an afterthought as well. So you can keep improving the rules without your application team and without it meddling with any of your business logic. So that's about the fine-grained security. And when you talk microservices, when you have a lot of moving parts, it's easy to get lost in something's not working. We don't know where it is stuck, right? So request traceability is I would say, a very crucial aspect. We did brainstorm on whether you should use something like an Eager, or there are many open source stacks for traceability. And then we figured out that the best way forward for us was implementing our own custom solution. So we have our reverse proxy, which will create a trace identifier and send it along the request headers to all the layers. And those layers are free to log that, and that way you can kind of have traceability and a view of, the time taken at each hop in the process. So that's on the application focus. I'll move on to the DevOps focus. Now, DevOps cannot be an afterthought, and DevOps is not just ops. A lot of people relate DevOps as ops, just the deployments and keeping the infra running. But there's a lot of dev thinking that has to go into it to make that happen. I'm not going to go into all the details. I probably want to spend some time on automation and infra and cost. I spoke about perimeter security. So it's equally important to ensure that your infra is secure before your application is secure. And talking about cost, you want to be able to run systems which are auto-scaling. You want to run systems which are optimally utilizing the infra. So right-sizing the infra, ensuring that your services are actually non-blocking so that they kind of, when their usage increases, they start utilizing all the CPU and all the, resources on the platform. And then you can have auto scaling rules which say that, add more infrastructure, spawn new nodes when you have those needs coming up. And automation and observability. So when you have many moving parts, I said request traceability is important because that's how, the developers know what's happening on the infra. But observability is a bit more broader. You have the operations team, you have your business teams, all of them want to know what is happening. So it is important to have a very solid observability stack as well. And I'll talk a bit more about in the data focus area. And automation, you have to be able to separate your configuration from your code. You have to have automated ways in which people can deploy the source code. You don't want to be hitting a roadblock in production and realizing that, the person who knew how to deploy is not available at that time. So you just want people who can use muscle memory to solve problems rather than think through it at that, time of crisis. So all of this can be solved through automation. And that's what we have focused on in Sunbird. Moving on to the data focus. Now, I spoke about observability. So observability, you can look at it as infra observability. You want the developers to have their observability views. You want the business teams to have their observability as well. So Lambda architecture is one of the most popular data stack architectures out there. The internet scale companies of the world use it. The big corporations in India, the unicorns in India all use it, and Sunbird uses it as well. So if you look at the Lambda architecture, you would see that it all starts with events, telemetry, audit, events, logs. So it all starts with events. It starts with defining what do you want to capture about something that is happening on your platform. So you generally your thought process would be who did what in what context, and sometimes maybe more, on what and why, as much as data as possible. So you start with those events. And those events, so you ensure those events are generated whenever your users interact with your platform. And you sometimes want to even generate events when your services interact among themselves, not just your users. And all these events flow into what we call the data pipeline, which is also called the speed layer in Lambda. So in the speed layer, you can kind of pre-process the data. You can avoid duplicates. You can kind of enrich the information with additional data that you want. You want to ensure that the event probably does not have any sort of PII information or too much details, because that's going over the network. So you don't want to tax the end user for sending a lot more information. So, you can get IDs and you can enrich those IDs with other business context information on your server side. So that's what the speed layer does. And then the speed layer pushes the data into two places. One is the data lake, which is the long-term storage. And the other is an OLAP engine, which is where you can do ad hoc analysis and you can do a lot of speed processing. So, so we are using Druid in Sunbird as the OLAP store. And Druid supports sub-second latency queries for, when you have like 100 billion events. So obviously now once you have all these events flowing in, and if you have millions of users, you will have billions of events flowing in. And then, at some point the cost of storage is going to hurt you. right? You cannot keep storing billions of events forever in a system which is queryable real time. That's inefficient. That's not good use of engineering resources. So what we do is that's where the data lake comes in, and that's where the batch layer comes in. The batch layer is a data summarization layer, which on a daily basis, it's going to pull all the raw events that have arrived in a particular day. It's going to summarize, generate a lot of business metrics, and it's going to store that data also into the OLAP store. So the idea is that you get more value per byte of data that you store from the summarizers, but the raw data is available for a shorter period of time for any sort of quick analysis that is required. And typically we've seen that adopters of Sunbird who set up this pipeline, they probably have raw data stored for maybe a month or so. And the data lake is stored forever. And if you want to do some historical data analysis, that's also quite possible, because you have Spark, or you can even plug in a Presto-like engine where you can easily run queries against your data lake, right? You can run structured queries against files sitting on cloud storage. So now I spoke about application focus areas, I spoke about DevOps, and I spoke about data. I mean, there are a lot of other focus areas as well, which I don't intend to touch upon right now. And all of this has been, all these best practices have been embedded into Sunbird. And we started this journey, 6 years ago. We've had multiple twists and turns. We've refactored some of the data stack. Of course, this is the final state that you're seeing, and it matches what is the latest and greatest in tech at the moment. So this is a set of all the building blocks, and it's sitting on a core foundation of a solid DevOps and infra-automation. And I tend to look at these. So Ashwin was trying to convey that Sunbird is not just a monolith. It is a set of building blocks which you can kind of pick and choose to tailor your solution. The way I look at it, each building block itself, you can assume is a system. So there's a lot in every building block that can be leveraged as well, independently. So for example, if you look at Anuvad, now, the microsite would say that it is a translation engine. It supports most of the Indic languages, at least most of the official languages. But if you go deeper, you would see that Anuvad is not just translations. It has the ability to generate, it has OCR capabilities, for example, because if you're uploading a PDF and you want to translate a PDF, your first step is extracting the text out of the PDF. So there's a lot of OCR capabilities built in. And if you have that, the developer eye, you can actually go in and use those custom trained Tesseract models for other use cases as well. Of course, is it documented? Probably no. We're probably keeping it at a building block level, but be aware that there's a lot under the hood as well. Okay. And there was a mention about Bhashini. So a lot of these building blocks are leveraged in Bhashini as well. So it's not just about the building block. There's quite a bit under the hood which you need to get in to explore. And how have we done all this? We've used all these tech stacks to assemble or create these building blocks. So as you can see, it's heavily polyglot. And we've tried to use the best tools, and we've tried to kind of embed the best practices also into the automation and the way we have done things. So it's not just about being polyglot for the sake of being polyglot. You want to be using a new tool because every time you introduce a new tool, there is an overhead of the learning curve, trying to figure out the best practices, trying to productionize it. But we have gone for these because we believe that if these building blocks have to be used for country scale or internet scale platforms, this is needed. And it's all open source. We have not leveraged any licensed software. We are only leveraging open source, and it's available for everybody. And we have gone to the extent of scaling some of these stacks and even making those scripts which are used to prove the scaling. That's also open source, basically. So you will find a Sunbird perf test repo for the curious ones here, where you would see JMeter scripts which pretty much prove all the APIs. And we've seen adoptions where the exact same scripts were reused with little engineering effort to prove that their setup scales as well. So that's the kind of thinking that we have been in. Yeah, as I said, the microsites go to the extent of building blocks. There's more under the hood, and the only way to explore is, just dive in, leverage what exists, and collaborate, and let's make it better, right? And every contribution counts. So if you're a developer who is trying something and you face some challenges, you can definitely add a couple of lines of documentation for the person behind you to make it easier, right? So no contribution is a small contribution. Everything matters. And through the course of this day and tomorrow, we will actually deep dive into how you can actually start contributing and how can you start leveraging some of these blocks.